All right, class, here's what I got here as far as the schedule change. We'll do 2.6 today, just depending on how fast we get through 2.6, 2.7. Of course, a review date is sort of built in as well. Thinking maybe we'll do it, but we have a test sometime next week sometime. We're good? All of chapter 2. I'll give you guys a revised study guide and we'll go from there. We're good? So we have this one right here. There is no school that I just found out or just verified.
That's my 2 weeks.
No, so there's no school on the 31st of March. There's no school on the 2nd of April. And then we have spring break after that. So that's kind of where we're at on that one. So let's jam. 2.6 is where we're at. Zoom. Zoom. All right. So we learned about a lot of cool stuff, right? We learned primarily how to get zeros off of polynomials. So rational functions, they are kind of like polynomials on top and bottom, if you kind of think about them. And so if you want to write it down, don't write down the stuff that's in the blue stuff. If you want to write down just the example 1, finding domain of a rational function. We didn't talk about domain for the polynomial functions here, because polynomial functions, everything is a domain. There's never a time a polynomial function does not work. We're good there? For rational functions, then that becomes a problem. So for this stuff like this, we've been studying it, just kind of give you an example here. So something like x squared plus 3x plus 4, all numbers work for that. You can plug in whatever you want. There's never a domain issue with polynomials, okay? The domain issue starts off when you have this right here. And then also when you have square roots, that's the other domain issue. Besides those, we don't have domain issues. All right, so let's go with it. Fractions and square roots are the problem. So let's find the domain of f of x is 1 over x. And the domain for this guy, you know what? Let's see. Let me see just real quick here how the book does it. Because you can either state all the numbers that don't work, or you state these are the numbers that do work. So depending on how they want it. And textbooks do it differently. Da, 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 da. Doesn't say. Let me just check the other side here. I'm going to go with, let me just check. I should check to see. 2.6. Yeah, all the numbers that don't work here. So for this one, we don't care about the top for domain. It's this little issue on the bottom. Just whatever numbers will make that to be a 0 because you cannot divide by 0. We good? Ooh, another presentation for second semester. Why can't you divide by 0? That'd be a fun, like, thing to make you say, Cool. So this guy, you can't be 0 because you can't have a 1 over 0. So the domain is, we usually write capital D for domain. We say all real numbers, because we're just talking about the ones that are hidden in the number line. So all real numbers except x equals 0. That's what works here. On this one here, what will cause a 0 on the denominator, in the denominator here? All real numbers except x is equal to -4 is our little problem there. All right, as well as on the homework, I think on the homework, I do want to be more consistent on the homework. So what I'll do is, like, before I leave, I'll make sure the dates are lined up for the homework thing. So I figure this, if we lecture on it, if we finish lecture on something, you have that time to do the homework. The next time we come together, I'll ask for homework questions, we're good? And then it's due that evening. So it'll be just sort of more consistent for that. Okay, let's jam. I got C and D. Oh, and this one has to do a little bit more work here, huh? Hey, that's why we learned chapter 2. In order to figure out what will cause this to be a 0, you could either know it, and you're like, oh yeah, I know this, or what you do is you set this guy equal to 0. And guess what? You can do P over Q, right? If it's 3 or higher, right? If it's degree 2, you can either factor, quadratic formula, or something called the square root method of solving equation, right? You could move the 1 over and take the square root of both sides if you like. I'm going to do factoring. So this is x and x. This is +1, -1. Everybody okay there? So notice I'm solving the denominator for 0 because it was a little bit more tricky. So I have answers of -1 and 1. So domain is all real numbers except x is equal to -1 and 1. That's my domain there.
You say plus or minus 1?
Perfect. Yeah, plus or minus 1 works just as well. Okay, D. I got x squared. I just changed it up just a tiny bit. X squared plus 1.
Whatever x squared is, it's not going to be negative, so there's no domain level.
Awesome. That's great, Isabel. That's perfect. So this little guy, remember, whenever you have a negative number, if you square it, it's going to turn out to be a positive number, right? So the smallest number you can have here is 0, because 0 squared will still give you 0. And if you add 1 to it, there's never a time
If you put I in
where the denominator will be equal to 0.
the 0 and 1.
Perfect. Yeah. Good question by Owen. And so here's a little problem. Whenever we graph numbers, this little x value is a real number. And this little y value is a real number. So on a graph, as far as touching the x-axis and the y-axis, they have to be real numbers for in order for
You
that.
say all real numbers? Yeah.
Domain here is all real numbers. There's no condition here. So good job, guys. That is perfect. Okay, so we got that taken care of. So rational numbers, here's what we got. Let me go back real quick here. For rational numbers, we got these two guys. We got a domain to learn because we have domain issues. And then we have asymptotes. We have vertical asymptotes. We have horizontal asymptotes. Then we want to be able to sketch the graphs. And then we have something called slant asymptotes. So it's all about asymptotes here with this stuff. So we've got to learn about that. Once we learn that, then we're like, oh, that's easy. I can graph this guy. Look at this. All right. And so let's jam with the horizontal asymptotes and the vertical asymptotes. All right, if you want to look at it on page 185 in your textbook when you come home, or if you brought your textbook with you. But vertical asymptotes are stuff like this right here. So it's the ones that go straight up and down. And there's x is equal to a. There's never a time where the graph will touch a vertical asymptote. And so it kind of goes like this, like that. And it may come down the same direction. It may come down a different direction. But that's a vertical asymptote. We usually put a little dash line coming straight down. Abbreviation for it is VA for vertical asymptote. Horizontal asymptote, again, sorry guys, real quick here. You don't need to write all that stuff down. We good? Maybe easier way just to draw it out. So here's your vertical asymptote. Draw it out. Looks like this. So I'm going to go like this. It has little arrows here. You got a dash line coming down. And then you have another arrow right here. So there's your VA if you want to draw it. Too much wording over here, too much wording. I want to give you guys the precise definition from the textbook. A horizontal asymptote, maybe draw it underneath horizontal. Horizontal asymptotes are stuff that it goes like this right here. So you put a dash line now horizontally coming like this. And let's say you had a graph that's going to do this. And right next to horizontal, you want to do this guy here. You want to put end behavior. Because a horizontal asymptote is about end behavior. we talked about in behavior for polynomials, right? Remember that? Like starts low, ends high, right? For this one, in behavior means, is he getting close to a certain number? Let's say y is equal to 1. Or y equals 0. You guys will be experts in graphing this stuff here by the time we're done with 2.6. And some homework problems. So horizontal asymptotes, what happens at the ends? Vertical asymptotes are the breaks in our graph. So over here next to VA, you can probably put break in graph. It's the breaks. All right, so let's do a few. In fact, let's do the ones that we just did before and thinking about them. All right, you guys tell me if I'm going too fast. We're good? We'll kind of slow down. Hopefully you're writing it down, not just doing it by osmosis. All right, and good. And don't have to write all of that stuff down. Just write just the stuff in red that I put in here.
Definitely we're going.
Okay, sorry. Okay, then I'm gonna
No, it's fine.
curve it a
You
little
said I
bit.
didn't have to and I did.
Gotcha. Okay, definitely don't write this down.
Ah.
So this one,
I'm not
this
right
one, when you do your homework, you're just going to refer back to page 186 as you start your homework. We're good?
Stop me.
But let me talk about it. So when you reference it, when you're doing your homework, you can see what's going on. We're good? Yeah. So we're talking about vertical isotopes and horizontal isotopes. Ready? Number one is vertical isotopes. So if this is a polynomial, any kind of polynomial. This means this guy's degree n.
Oh, is that the thing where it was like a number? Oh,
They're all connected, right? They're all connected by this little sub n and n.
Yeah, okay.
So this is your degree n on top. This is degree m on the bottom, right? So this could be x to the 7th or x to the 5th or x to the 2nd, right? And so once you get it down to there's no common factors, your vertical isotopes are the stuff that makes your denominator 0, that's your domain, your breaks. We can do some problems in just a second here anyways. Second of all is, number 2 is kind of weird. Look at this here. Sometimes there is no horizontal isotope. Sometimes there is, depending on what's happening here. So we'll practice with it as well. So if n is less than m, if the degree on top is going to be smaller than the degree on the bottom, you have yourself y equals 0, and that is your horizontal asymptote. Again, we'll practice enough times with this in just a bit here. If the degrees are exactly the same, like this is to the 3rd power, that's to the 3rd power, then what happens is we just get the ratio of your leading coefficients. We good? We just divide those out, and that's your horizontal asymptote. And if the degree on top is bigger than degree on the bottom, then there are no horizontal asymptotes. We good? So degree on top is bigger, degree on the bottom is bigger, y equals 0. If they're the same, it's a ratio. If degree on top is bigger, what we call it improper. If it's an improper fraction as far as degrees are concerned, then we have ourselves no horizontal asymptote. Let's practice a few times here. Or let's actually review a few things here first. So let's go with it here. Looking at this little piece right here. So first of all, vertical asymptote. Everybody okay with there? It should be x is equal to -1. There's your break in your graph. It causes the 0 on the bottom. Second of all, notice the degrees. Degree 1 here, degree 1 there. The degrees are the same. So that means if you were to divide 2 divided by 1, your HA is equal to y equals 2. We good? I should do this here. VA is equal to -1. Okay, we good there? Don't need to write it down, just kind of think with me here. We'll have enough practice doing them in just a second here. Let's do the next one. Boom. Ooh, ever a time this guy's gonna give you a 0 in the bottom.
No.
Okay, so no vertical isotopes, VA, none. HA? Yeah, HA, this is degree 0, right?
If the domain is everything, there's no vertical isotope.
Say again, Abe? Good.
Like, if there's no domain issue, but it never gives you 0 on the bottom. Well,
Correct, yeah, can be, There are times where you have a domain issue, but not a vertical isotope. We'll cover that in just a bit. But everybody okay with, this is degree 0 on top, this is degree 2 on the bottom. That means the bottom is bigger. Therefore, it should be y equals 0. Okay. So good so far. This is quick, this is easy. Next one is, ooh, how fun. This is x minus 1 to the second power. Okay, so notice on this one here. Ooh, notice also you have this little second, x to the second over here. So do we have vertical isotope? Yes, we do. Vertical isotope at x is equal to 1 because of that little issue there. Do want to mention something else here real quick. That little 2, see that little 2 there? What happens here is the fact that this guy's going to go in the same exact direction. So notice these guys go in the same direction because of the squared. So we'll cover that in a bit here too. Okay, as far as horizontal isotopes go, boom, boom, boom. I look over here. This is degree 0 again. That's degree 2. I know y is equal to 0 as my horizontal. Essentially, that is it. We like to see our y-intercept real quick here because that's easy to tell. And we like to see if there's any x-intercepts as well. And with that, we plug it all together. So let's try some examples here. Example 2, finding some horizontal and vertical asymptotes. Let's go. Boom. So VA, I'll go vertical isotopes first, and then we'll do horizontal isotopes. All right, and these are the same problems that we had for example 1. When you guys see the connection, and then we'll add an extra few problems here. Vertical isotope. Let's see. That's a problem at 0, is that right? So I have a vertical isotope at x equals 0. Because that's what produces my break in my graph in the beginning, right? There's a break in the graph, that's when my vertical isotope is going to stand out. Okay, horizontal isotope. What did I say? Well, let me start bugging people here. Outside the room. Abe. Horizontal isotope. No. Vertical isotope. Everybody okay with x equals 0 though? For the horizontal or for the vertical? Horizontal would be this guy is degree 0. This guy's technically degree 1, right? So therefore, we're going to have y is equal to 0 because it's a proper fraction as far as degrees go. But let's get a little bit more depth into this here. You guys talk to me here. If this guy, horizontal isotopes are talking about what happens at the ends, right? And so if we talk about this right here, let's see. If I plug in a 10 into this, notice this is going to be 1/10, right? As I'm going off to the right-hand side. If I plug in 100 into here, this is 100, very close to 0 or no?
Yeah.
Yeah.
You're never gonna actually hear them.
Yeah.
Correct, yeah. So if I plug in, the further I go out to the right, notice the closer 1 over that number is going to get closer to 0. Right? Same thing happens on the other side. As I go to, as I go to here, 1 over negative 100. But notice that number, because it's just a 1 on top, it's a unit fraction, right? So the bigger the denominator gets, the closer that number is going to 0. And that's essentially what a horizontal isotope is. We're good? So y is equal to 1. Okay, are we good there? Next. Let's go with this one now. Vertical asymptote. Camille, we're doing 2.6. I'm just gonna follow along here. All right, the problem area happened. So notice for the domain and for the vertical asymptote, we do the exact same thing. We ask ourselves, when does this guy give me a 0? -4. Exact same question that we do for domain, except there's gonna be a tiny, tiny, tiny slight twist to it. Horizontal asymptote. Owen, there you go. Another one to pick on somebody here. Owen, horizontal asymptote for B.
Wouldn't it be the same as A because the degree is still the progression?
Perfect, yep, This is degree 0, this is degree 1. We have ourselves that little guy happening.
Wait, out of curiosity, couldn't the 1 on the top, because 1 to any power is still 1?
Ah, good, yep.
Yeah, couldn't it be, if you made it a higher power, it wouldn't change the problem, but it would change the asymptote, right? Whatever they're called. Because then you have an improper fraction as far as
Yeah, whenever I say degree 0, what I really mean is any x values. So any x values here are degree 0, because so it's degree of the polynomial. What's the degree of the polynomial on top is 0. Degree of the polynomial on the bottom is 1.
Because technically the degree of 1 is 1.
Yeah, the exponent here sitting as a 1, yeah. But degree of the polynomial is 0.
Any number to 0 power is just 1, right?
Okay, let's go some more here. Let's see. C and D. Da, 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 da. All right, you guys, how you guys doing so far? So good? Easy ones here still. Let's see. Maddie, if we can remember from exercise 1, what's the vertical asymptote or isotopes? Yes, there are 2 of them this time. There's a +1 and a -1. So there's 2 breaks in our graph this time. Okay, and then horizontal asymptote. Da, 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 da. Horizontal asymptote. And Dylan in the back. What do you say here? The degree of this polynomial is 0, right? The degree of this polynomial is 2. It's still a proper fraction.
Yes.
So I'm going to go y equals.
I'm not entirely sure. I'm still trying to sort through my notes.
Gotcha. Okay. It should be just y equals 0 because of the degree difference there. And the degree at the bottom is bigger than the degree on top. Okay. Is that okay, Dylan? Okay. Okay. Making sure. And last one here. For this, maybe? No, we got 2 more. Boom. For D. Vertical asymptote. Zero plugged in still gives you a 1, so there's no break in them. Ah, good. Hold on. So domain is all real numbers, right? There's never a break in my graph, so therefore there are none VAs. Camille, doing okay? Okay. I don't want you to get too lost here, so ask me the questions, okay, as we go through them here. Horizontal asymptotes. Again, degree 0 on top, degree 2 on the bottom for the polynomial. We good? And so we have y is equal to 0 still. Are we good? And I would say normally that's kind of what happens. You sort of get this flavor for them here. Let's do 2 more. 2 more, a little bit different than the ones we did before. I got E and F. If you're going to write those down. All right. Vertical asymptote. Charlie, have I picked on you yet or no? Yes, all right, cool. Charlie, what is the vertical asymptote of this guy?
Would just be ±1.
Plus or minus 1, yeah. So when we solve it for 0, we're going to get 2 different answers. Plus or minus 1, there are 2 vertical asymptotes here. Boom. Land in horizontal asymptote.
Is this the one where it's, since they're both a degree of 2? I'm trying to remember what you said about this, but I think it was like, you write it as like a fraction, right?
Absolutely. So notice degree 2 on top, degree 2 on the bottom, they are both the same. So what we do is we just say, look, it's going to be the coefficients, the leading coefficients.
2/1, which is just 2.
Boom. Okay, this one's a new one. This one, we haven't touched this one before. So let's talk about F. F is it's a long one here, so paying attention here. So vertical asymptotes. What are my vertical asymptotes first? Well, we can't figure that out yet. Ah, hold on. Let's talk about it here. So
I was
domain.
just thinking about what if you put in there would get you 0. I think it's plus or minus 3, but I might be wrong.
I got -3.
Plus 2.
2, yeah, plus, because if it was 3 and 3, it would be a 9 down here, right? Instead of, yeah. All right, a few things here, putting our thinking caps on just for a little bit. Ready? This is a good clarification. If I were to factor and put things over here on top, so in factored form, let's do this here, x² plus x minus 2, this would be x plus 2x minus 1. Tell me if you guys agree. So in factored form, this one right here, this would be a -3 plus 2. Tell me if you guys agree. Okay, so thinking caps on, ready? My domain, let's go back to domain, because domain is important here. Domain is all real numbers except, and you guys talk to me, except what and what? X is equal 3 and -2. Are we good there? Everybody good? For domain. So now let's jump to vertical asymptote. Vertical asymptote says it has to be in reduced form. You cannot take any factors that are the same. So for vertical asymptotes, domain deals with the original problem. The vertical asymptotes deal with the reduced form. Are we good there? I think we'll get to something like that in the notes here. So for vertical asymptotes, it's going to be x is equal to 3. Only the 3 is the vertical asymptote. It always comes up, Mr. Hunji, what happens with the x equals -2? It is something called a hole in our graph. But let's go back to, Dylan, let's go back to horizontal asymptotes. What do we have here? One, yeah. We want to write it as 1/1 or just 1. It's fine. Okay, everybody good there? Domain deals with the original problem. Vertical asymptotes deal with the reduced problem, or the one that has no factors yet. So pull out all the factors. Okay, and then the extra little piece, let's write it in here. We have a hole at x equals -2. We'll deal with that as we start drafting these guys. Okay. Tristan?
So like for a homework problem, would you have to write if it had a hole, like hole?
Yeah, for the homework, when you're saying what's the horizontal asymptote, what's the vertical asymptote, just say you won't have to clarify the hole yet. When we start graphing, we will.
Why is the hole?
Because it's was not part of our domain, and it was not part of our vertical asymptote at the end. F And let me let's see, let me plug in an extra problem here.
Why is the vertical asymptote just 3 and not negative 2 as well?
Perfect, guys. Thank you so much for asking, because that's what we're here for. It is because of that's what happened. The x equals -2 canceled off as we were reducing it in form.
So for the vertical asymptote, you want to factor it out first, and for horizontal, you can stick to coefficients.
I don't know. Let's go backwards here. So for domain, you're looking at original problem. Original problem for domain. You don't care about if it reduces or not. And then for vertical asymptote, you care only about the reduced form. The other one's a whole. And then for the horizontal asymptote, you go back to our rules for horizontal asymptotes. Is if it is proper fraction, y equals 0. If they're both the same, it's y is equal to the coefficients of those. So the ratio of the coefficients. Ratio of the leading coefficients, technically. Landon, go ahead.
For horizontal, would we go back to the original problem or the,
Ah, good. Yeah, for the horizontal, you go back to the original problem.
Okay.
Maybe that's what Dylan was saying, right? So domain and the horizontal has to deal with original problems.
Yeah.
I think we could deal with the other one by ourselves. Okay, so let's jam. This is now, again, don't write this down. We're getting into sketching of the graphs here. We did a lot of work today here. So this is page 187. So again, write down 187 in your notes. Here's how we are going to do these problems. We're just going to sketch a whole bunch of them. We're going to be expert sketchers of this stuff. So first things first, you want to put into reduced form. Just want to factor it out, see what you have. Because from then it's really easy to do stuff. So simplify will be step 1. Step 2, find the y-intercept, because that's so easy. You plug in a 0 and boom, you get your y-intercept. We got a point already. Step 3, find any x-intercepts. Step 4, find any vertical asymptotes. Step 5, any horizontal asymptotes. And then if you need more points, go for it. But we usually will not need any more points. Good? So reduced form, y-intercept, x-intercept. Technically, look at some intercepts, look at some asymptotes. Let's see what we got. And so now let's jam. Can we sketch this little guy? Let's see how much time we have. Yeah. Okay, so we are sketching. So g of x is equal to 3 over x minus 2. Simplified form, I'll just kind of follow the same steps here. So simplified form is this already. We did not need to factor. We did not need to do anything. Step 2, I'll just do y int for abbreviation's sake here, y int. So this one, you really don't even need to do the work on it. If you want to show the work, you plug in the 0 for the x. -3/2 gives me the y-intercept. Step 3 is the x-intercept. So again, over here, back to the original equation for intercepts. And what you do is you just take your denominator, I'm sorry, your numerator only. So 3 is equal to 0. Just take your numerator only from your original problem. And there are no x-intercepts. We're good? That's crazy. This guy never crosses the x-axis. Step 4, finding the vertical asymptotes. So this one goes back to number 1, right? This is the simplified version. Just a second here. So simplified version still causing a 0, 2 still a problem. Is that right? So VA x equals 2 and horizontal asymptote. What do you guys say for the horizontal asymptote? y equals 0, right? Boom. Tristan, what's your question?
What does it say after 3 equals 0?
Oh, none. That didn't help either, huh? So none. So let's go over here. So expert sketchers, here we go. Here's my x-axis here. Let's see, we have a y-intercept at -3.5, which is, or -3.5, sorry. That's -1.5. So my only dot is about right there. I have a y-intercept, no x-intercepts whatsoever. I have a vertical asymptote. Actually, let me change it to black, which helps. So I have, actually, no, let me do this in red and then we'll do that in black. So 1, 2, 3, 4. I'll go out 1, 2, 3. I'll go out 4 because there's nothing on here that has to go out further than that. So vertical asymptote at 2. I got this right here. And I have a horizontal asymptote that goes like this. Okay, guys, this is so cool. If you guys remember from back to Algebra 1 days, do you guys remember, did you guys ever graph this stuff in Algebra 1? Make a table, you had to make at least 5 points, if maybe like 7 or 9. Okay, Algebra 2 says, let's analytically draw this. So this guy cannot cross the x-axis ever. We good? It cannot cross that vertical asymptote either. We good? So question is, what's the graph that does that? That has to go through -1 and 1/2. And that has, yeah, and then at the ends, right? At the ends, when it goes out this way, it's going to get close to 0. It goes out this way, it gets closer to 0. So let me draw it real quick here. So your only options are, it's either goes like this. It's either going to go on top like that, or it's going to go in the bottom. Which one do you guys say? The bottom has to go through that red dot, right? Boom. Okay, so if it goes to the bottom, we'll talk about this here, but this little, the exponent on x minus 2, it's an odd exponent. We good? In this case, we call the split behavior, which means these guys are going to be split from one another. Okay? If it's an even number, the book doesn't talk about it as much, so I'll just kind of mention as we do these here. So once you draw one in, you know how the rest of it flows.
So if there's one on the bottom, there has to be one on top.
Yeah, because this guy's an odd exponent. If it was even, they would be going to the same direction. I'm not sure why the book doesn't talk about it as much, but again, we'll just mention it as we go. All right, guys, let's go with it. Less than 10 minutes to go. Let's see how many of these we can do. And tell me if I'm going too fast. We good? Otherwise, we'll just jam with it. Okay, does that make sense? And look at this. This is so cool. We graphed this guy based upon one single dot. That's it. No table of 9 points. One dot, and then we just kind of knew horizontal and vertical asymptotes. Isabel?
Pretty sure I was trying to graph that one problem that we had for the oral final, that then you like took off at the end, because it was split like that,
Uh-huh.
and like I put like so many points to try and graph the thing.
Mm-hmm.
That's a lot easier.
A lot easier. I think so, yeah. Okay, let's jam. Let's go for it here. So 2x minus 1 and x on the bottom, go. Do it together. Let's see if we can get through most of this here. Let's see what we got here. 1, 2, 3, 4. And then we got one extra one here. Okay. So number 1, simplified form. And I'll just kind of keep on writing. You guys tell me. So this one, again, there's no factoring involved. There's no x squared in here. So the simplified form would be 2x minus 1 over x. That's it. X don't cancel because the 1 does not have an x next to it. All of them would have to have x's next to them to cancel. Step 2, the y-intercept. We have to plug in for the zeros, right? And if I do that, I get to plug in the 0 on top, but I also plug in the 0 on the bottom, and that's a problem. There are no y-intercepts to this problem. Are there any x-intercepts to this problem? Let's see. we're gonna use the original denominator and we're gonna, I'm sorry, numerator, original numerator, solve for x. So add 1 to both sides, divide by 2, and we get ourselves a 1/2. Perfect. Step 4, vertical isotopes. Vertical isotope is, stop picking on people here. That's cool. Tristan, I think I haven't picked on you yet. Second. Sure, I'll let you guys catch up because I know I was kind of jamming with the problem. 0, absolutely. There's only one thing on the bottom is x, and x, the only time it's going to be a problem is 0. And 5, horizontal asymptote, Isabel.
The ratio of the coefficients, right?
Yep.
So it's just 2 and 1, so it'd be y equals 2.
Y equals 2, perfect. Okay, guys, based upon that, boom, 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 boom. 1 dot, we know the isotopes. Let's see if we can graph it again. Let's see if we can graph this guy. I don't need to go out that far either. The only time I need to really go out horizontally is because of the x-intercepts, and that's a 1/2. So I'm going to go out 1, 2, 3, 1, 2, 3, 1, 2, 3, 1. I'll just go 1, 2, 3 everywhere. That's all I really need. Boom. Okay, so now I have a x-intercept. It is right here. It's exactly at 1/2. Boom. I have to cross this somehow, sometime. I have a vertical isotope. X equals 0, so right along the y-axis. Hey, no wonder that's why I didn't have a y-intercept. I have myself a vertical isotope right there. That's why I never crossed. There's a break in my graph right there. And y equals 2. My horizontal isotope comes across right here. Boom. Okay, based upon my dashed lines and based upon that little dot, can I graph my graph? And we usually will do it right here first. We usually want to make sure our point has connected like that. Therefore, the flip side has to go from the top, has to be going out this way then. Boom, that's the only way that it could work. Cool. Okay. Let's see, I'm going to try to get through 1, 2.
So the asymptotes are almost like walls, right?
Uh-huh.
You like can't cross over them.
Let's see. Let's talk about this here too, because this is important. Vertical asymptotes, you may never cross them ever, ever, ever. Okay. Horizontal asymptotes, because we're just talking about in behavior, they'll just get close to this asymptotes at the end, but sometimes they may cross. Like if we have more than one vertical asymptote we'll get to, sometimes you will have kind of like something like this that crosses right through here. So horizontal isotopes you can cross because it's just talking about behavior at the ends. Vertical isotopes cannot.
Within that line, that's an example.
Is an example. Isabel.
How do we know if the second part of the graph is like they have no enough?
Which one?
If the second part of the graph we don't have any points, how do we know?
Oh, this one right here?
Yeah.
It's because we have split behavior right here. And if we didn't, then there had to have been another x-intercept right here somewhere. There was no way we could get back to that y equals 2 line without it having to cross the x-axis again. And so split behavior and then that little guy right there. Cool. Do we have time for one more? No. Okay, let's stop here. We haven't finished 2.6 yet. So don't. Let's see if we can start the homework or not. Let's see.
We can just start the homework, and if there's stuff we don't understand, we just stop there.
Yeah, let's do that. At least start the homework a little bit here, but it won't be due. It's not going to be due Wednesday. We'll push it off to Friday then.
Thank you.
Sure, guys. Enjoy the rest of your day.
This is not
what color is that? Mustard?